Welcome back. This is the second of our series of short videos introducing grade and appraising the evidence. So by now you will hopefully have watched video 1 and spent a few minutes on the brainstorming exercise. Now, spoiler alert, this video contains many of the answers to the brainstorming exercise. Right. Let's start with a couple of completely made up forest plots, just for purposes of illustration. So here we've got a meta-analysis comparing magic with muggle medicine for treating Quidditch-related injuries. The outcome here is fully healed injury at 3 months follow-up. Now, these two forest plots have the same numbers of studies and participants, similar numbers of injuries overall, and similar pooled effect estimates. You can see here total number of participants, here and there exactly the same. Very similar pooled effect estimate here, risk ratio of 1.28, 1.39 here. Similar confidence interval as well, so similar level of precision. Now, what does differ here? Well, that's basically how consistent these effects are between the different studies. And in the top figure, you've got a huge spread of study point estimates. And as you can see, some confidence intervals here don't overlap at all. There's a lot of heterogeneity in those studies that isn't really explained or immediately explained. That's reflected by the I-squared, which shows that 90% of the variation in effect estimates is not due to chance alone. Now the bottom graph is much more consistent. The I-square here is 0. The confidence intervals overlap. So overall, this forest plot shows consistent evidence across the studies that magic is more effective than muggle medicine at healing injuries. Now, looking at those two forest plots, are you going to trust both equally? Now here's another example. This one compares cognitive behavioral therapy with Jedi mind control for preventing excessive smartphone use. Now, here we've got, again, the same number of studies, same number of participants. In this case, we've got a consistent effect across the studies, all pointing to the right, so favouring Jedi mind control. Consistent effect, unlike the previous example. So what's the difference here? Well, although the direction of effect is the same in both of these graphs, the lower one presents a much more precise estimate. And that is reflected by the precision of the individual studies. So ultimately, the diamond in the top figure has a much, much wider confidence interval than the one at the bottom. Now, again, in this case, are you going to evaluate the strength of the evidence presented in the top and the bottom plot equally? Probably not. Now, this is what grade looks at. Grade helps to systematically evaluate and record all the basically all the things that don't seem quite right with your results, including your forest plots. Okay, so what's grade? So in the first video, we saw how important it is to not just estimate an effect, but to assess how much we can trust that estimate. Grade is basically a framework to assess how much we trust the evidence. Another way to look at it is to see grade as a framework that makes certainty and uncertainty more explicit and transparent. To do that, grade uses a systematic approach that assesses separately the different aspects that can affect the reliability of your findings. So in the hypothetical examples that we gave, it can be systematically assessing the consistency of your evidence or the precision of your evidence. And depending on whether you've got concerns about those, then the strength of your evidence may be affected. So ultimately, grade is a tool for rating the overall quality or strength, if you want, of the evidence. In the context of grade, we're going to use interchangeably terms like quality or strength or reliability. Now, I just want to add something there. We need to distinguish between trusting the conduct of the review versus trusting the findings of the review. Grade is all about assessing whether you can trust the findings of the review, not whether the review was conducted well or not. With grade, it is assumed that your review was appropriately conducted. All right, so where does grade come from? Very briefly, the origins are in guideline development. And originally the idea was to have a framework to inform not so much the strength of the findings of reviews, but to inform the strength of guideline recommendations. It's used very widely. So, for instance, WHO, NICE, Cochrane, very keen on it. Now, to give you an example of strength of guideline recommendations and how that relates to strength of evidence. A while ago, I don't know if they've updated those guidelines actually, but anyway, the Scottish guidelines SIGN guidelines on colorectal cancer prevention basically recommended eat your 5 a day, and that may reduce your risk of colorectal cancer. I'm paraphrasing the recommendation badly, but it doesn't matter. Question is, how much do you trust this? In this context, it's based on fairly weak observational evidence. So in those guidelines, there is a recommendation, and also there is a comment about the strength of that recommendation. In this context, probably weak. Okay, now in a systematic review context, it's a bit different. We're not formulating recommendations for practice directly when we're writing our conclusions, but we're presenting findings and formulating conclusions about the evidence. That partly includes formulating conclusions about the strength of that evidence. So whether it's guideline recommendations or systematic reviews, in both cases, we need to know how strong our evidence is. All right, so where do we start? Starting point with grade is your review question. So you're going to assess how strong your evidence is to inform your review question. And this is framed by your PICO. So the question is, how strong is the evidence for a given intervention relative to a given comparator in a given population and for a given outcome. And a systematic review will provide an estimate for that PICO. Now, your job in this context is to rate the quality of that evidence. And to do that, you will apply quality ratings for each of your outcomes of interest. Now, if you've got more than one intervention or more than one comparison, then there will be a separate quality rating, not just by outcome, but also by comparison for a given outcome. Now, this is important because the strength of your evidence may vary from one outcome to another. So, for instance, evidence informing recovery from Quidditch injuries may be different to evidence on, say, the side effects of magic versus muggle medicine. May have a different set of studies, different evidence, which may have different levels of strength, depending on whether it's about recovery from injury versus safety of intervention. Now, your quality ratings will be made according to your assessment of 5 different aspects that may affect the reliability of your finding. So in the example we discussed, some of these aspects can include consistency and precision. These aspects are called domains in the grade context. And with grade, there are 5 key domains that you need to take into account to rate your evidence. Now, the 5 domains are sort of the pillars of the grade framework, you could say. And with grade, the evidence available for each outcome of interest is assessed based on these 5 domains. So there's risk of bias. So in the session on study quality and risk of bias, you looked at how to assess the quality of individual studies. Now with grade, it's a bit different. The risk of bias here is to be understood as what is the overall quality of all the evidence for a given outcome. So for risk of bias, you'll be looking at the quality of all the evidence rather than just the quality of each individual study. Then in precision, so we've discussed it in the forest plot on Jedi mind control, it's about making a judgment on how precise your estimate is to inform a review question for a given outcome. There's also inconsistency, so we've talked about that. It's basically about how consistent the evidence is for a given outcome, as in the example of the Quidditch. Now, indirectness. This is another concept, not necessarily well named. The idea here is essentially about how applicable your evidence is to answer your review question. So in other words, is the evidence generalizable to the population, to my intervention, to the comparator and the comparison I'm interested in, and to the outcome that I'm interested in? So to give you an example, my review includes evidence for adults, but my review question is about children, or I don't know, older children. Question here is, how applicable is my evidence? Am I going to trust it less to inform my review question if it's in a different population to the one I'm focusing on? Another example is what's often called, well, surrogate outcomes. So my review question is about reducing cholesterol. But ultimately, I'm not just interested in reducing cholesterol. Ultimately, I'm interested in improving, say, survival outcomes. Now, in my review, there is only evidence for cholesterol reduction. There is evidence that my treatment reduces cholesterol, but ultimately, how does this improve survival outcomes? Can I make an indirect judgment about the benefit of this intervention on survival? Okay, and then the last domain is a sort of box that contains several things. The most common one is publication bias. So you've talked a bit about that in your session on meta-analysis. In some cases, the quality and reliability of your evidence might be affected by, say, evidence of publication bias. In other words, some more favourable studies for a given intervention are likelier to be published and presented than less favourable ones, and that could affect the reliability of your outcomes. And then, amongst other consideration, grade can look at, well, if you've got observational evidence, the size of your effect. So if your intervention has a large effect for a given outcome, then it may be more reliable, regardless of any other factors. It can also look at confounding, what's called plausible confounding. So whether and how well the evidence accounts for confounders. For instance, additional medication that is given to a patient and how that might affect the outcomes for that population ultimately, whether that's accounted for properly. And a final concern that is mentioned in grade as well is the dose response effect. So that's basically about assessing whether there's evidence that the efficacy of a given treatment can be partly explained by the dose, its intensity, effectively. All right, so these are the 5 domains. Now, for each of those 5 domains, the review authors will have to express their level of concern about it, about the available evidence. So, for instance, in the Quidditch example, there was evidence of significant heterogeneity. So you had maybe a serious or even a very serious concern for the inconsistency domain. Or your evidence was at high risk of bias overall, so you have concerns about the risk of bias domain. 3 levels of concern. You can have no serious concerns, or very serious concerns. In the example where we had 90% I-squared, maybe you could argue that you didn't just have serious concerns, you had actually very serious concerns. You'll give even more weight to that particular domain. So once you've specified what concerns you have about each of your 5 domains, you're going to give an overall quality rating to the available evidence for each outcome. Now, is this a subjective exercise? Definitely. Is this arbitrary? Definitely not. Ultimately, the idea here is that you're making a transparent decision. It's a decision that's made by the review team, in fact. And that decision is informed by an explicit assessment of the different domains that can affect the overall strength of your evidence. 4 different possible overall quality ratings. You can say that ultimately the strength of the evidence is high, moderate, low, or very low. It's as simple as that. Now, what did these quality ratings mean, in effect? So if you've got an overall quality rating of high, it means that, in other words, you have a lot of confidence that your effect estimate is similar to the truth, is close to the truth, effectively. In other words, you have a lot of confidence that a true effect is similar to the estimated effect. And even if you conducted further research, it would be very unlikely to change the confidence that you have in that estimate. And as you'll have guessed, basically the further ratings just highlight greater uncertainty and less confidence in the fact that your estimates may be is close to the truth. So moderate, probably close to the truth, and further research is likely to have an important impact and may change the estimate. Low, the true effect might be markedly different. Further research is very likely to have an impact on your confidence in the effect estimate. And very low, the true effect is probably markedly different. So we're very uncertain about the estimate. So ultimately, this is helpful to bear in mind when you're assessing each of your individual domains. You're asking yourself, okay, there is a concern there, and this means that my estimate, my effect estimate, is likely to differ from the truth. How does this work in practice? One way to look at it is to approach it a bit like some kind of game, like Super Mario. Like grade, Super Mario is effectively an obstacle course with obstacles of varying difficulty and complexity. In grade, your obstacles are effectively your domains. Now, in the video game, you start with a certain number of lives, and then you face a certain number of obstacles. And with each obstacle, there's the possibility that you lose a life, and then you move on to the next obstacle, and so on and so on. Now, your starting point in this game, if you want to call it that, determines the level at which you start, or if you want, the number of lives you have. So, if you've got an RCT, the starting assumption is that the quality of your evidence is high before assessing any individual domain. Now, when you assess, say, the risk of bias domain, you may find that you have overall no significant concerns about the evidence for a given outcome. So you don't downgrade the evidence, which still remains high. And then you move on to the next domain. Now you find that you have serious concerns about, say, the precision of your estimate. In this context, you think that the concerns are sufficient to downgrade. So you downgrade by, say, 1 level, which brings you down from high quality to moderate quality overall. You start with high, and then you download, say, by 1 category if you've got a serious concern. If you've got a very serious concern, you may downgrade by 2 categories. So, for instance, from high to low, or from moderate to very low. So the idea here is that grading, or more specifically here, downgrading, is cumulative across all domains. So you have concern, 1 serious concern for risk of bias, and then 1 for imprecision. 1 plus 1 is 2, so you downgrade by 2. So you jump from high to low. As simple as that. Now, if you have a review of observational evidence, then your starting point in grade is not high, it's low. So you may downgrade the evidence in some cases. For instance, you have concerns about risk of bias or precision and so on, but you may also upgrade the evidence. For instance, if you have a particularly large effect, or if you have what's called dose response effect, where you show sufficient evidence that actually, if you increase the dose of your intervention, for instance, this yields a stronger effect estimate. Right. Finally, once you've assessed all your domains, you will fill in what is called a summary of findings table. So for a given outcome, you will fill in information about outcome here, and then number of studies, the design. So for instance, if you've got RCT, you're starting with high. And then you also need the number of participants in the treatment and control arm for your given outcome, your effect estimate, including confidence intervals, and then you fill in the red cells, so the little obstacles in that obstacle course. So you have either no concerns, serious concerns, or very serious concerns, as we've discussed. So if you have no concern for risk of bias, you just put no concern here, indirectness, and so on and so on and so on. And depending on the number of concerns you have and how serious they are, you will inform the overall quality rating, which, as we've said, can be either high, moderate, low, or very low. The lowest you can reach in this exercise is very low. Even if you have concerns about every single domain, the lowest you can get is very low. Now, a really important element in this exercise is your footnotes. So whenever you decide to downgrade, you will need to justify your decision. So for instance, in precision, you can say, I don't know, you had concerns because well, the effect estimate was very imprecise, and your confidence, as expressed by the wide confidence interval, or something like that. All right, so just a very quick recap. With grade, we're assessing overall strength or quality of the evidence according to 5 domains. For each of these domains, we have 3 levels of concern, which can be either no concern, serious concern, or very serious concern, and the assessment of these domains will inform an overall rating of the strength of evidence for a given outcome. In the live session, we will be applying these domains and running a grade assessment. So there'll be time and opportunity for plenty of questions, should you have any. I look forward to seeing you then.